Today's lesson is dealing with a specific situation in probability, and what it's called is a permutation. Now, you need to know the word permutation, but more importantly, you need to know the fact pattern or the situation where a permutation would be used specifically on your calculator. A permutation is an arrangement of objects where order matters. And the formula for permutation is NPR. N and R are lowercase, more like subset. The N is the number of objects fill R slots. Now, while that's nice, and there's actually a little bit more elaborate formula behind this, as you're going to see in a couple of minutes, we can use our calculator to do this for us. Factorial, or the exclamation point in math, means the multiplication of all integers from that integer down to 1. So in other words, just shorthand. So 6 factorial means to multiply 6 times 5 times 4 times 3 times 2 times 1, okay, which is 720. And again, this is something that's easily done on the calculator without having to spell out all the digits. When we do permutations, one of the things that we're going to see that's helpful to us is using what we call the box method. We actually did this a little bit before. And where this kicks in is where there is a restriction on the arrangement. Okay? All right. Now, this will make a little bit more sense when we go through examples, okay? And actually, what I'm going to do is just put down here permutations in the box method with restrictions. That definition should go down there. And permutation in the box method just means I'm going to put, we call it box, but they're really dashes, so I don't know why we call it box. But what it means is we put into each of these boxes the possible outcomes. So if we were doing our factorial, it would be 6 times 5 times 4 times 3 times 2 times 1. Okay? All right. Sorry for that confusion, but now we have 3 people, Sandra, Lisa, and Patty, who are going to go to the movie, and we want to know how many different ways they can line up. The first thing you have to recognize is that is there a different arrangement if we put them in a different order? Okay? And hopefully you're recognizing that the answer is yes. So we have 3 girls that are going to the movies. And the way we would look at it is 2 different ways. We can either say 3 factorial or 3p3, meaning we're choosing 3 out of the 3 girls. Okay? And either way you do that, and I'll show you this in the calculator. I'll show both of them. The way you do factorial is you put the number first, then you go to math. This is all under probability, so you scroll over to probability, and you scroll down to number 4, and it comes up factorial, and then you hit enter again, and it gives you the number 6. If you were doing the permutation, you have to put the n number first, the 3, go to math, go back over to probability. You go down to NPR, hit enter. You put the R number, 3 again, and you hit enter, and you get the 6. Okay? So either one of these gives you an answer of 6. Just to show you what we're talking about, the way they could have lined up for the movies is it could have been Sandra, Lisa, Patty, or it could have been SPL, it could have been LPS, LSP, PSL, or PLS. So those are the 6 different arrangements that we could have had here. All right? Just to demonstrate why this works in the way we're talking about. The key is that you recognize that each lineup is different, okay? And one of the things I'll talk about is what are the key buzzwords to recognize, okay? All right. I have the letters MATH, and I want to know how many different four-letter words. Now, when they talk about this, they don't mean words, and that's why it's a quote, to spell a word, but it's a configuration of it. Well, I have four letters, all different. So we're talking about either 4 factorial or 4p4, and in either case, that's 24 arrangements. Okay? Now, just to show you, I have the letters TILES, and I want 3-letter words. Okay? Again, they're all different letters, so it would either be 5p3, because I'm only choosing 3, or here's where that box method comes in. I only am choosing 3, so I have 3 boxes. I could take 5 for the first box, then I'm down to 4, then I'm down to 3. In either case, that gives me 60. Okay? And then finally, I have 10 flags. I'm going to select 4 of them. So that's either 10p4 or 10 times 9 times 8 times 7. And in either case, that's 5,040 different arrangements of flags. Okay? All right, so now let's take some derivatives of this. Now, suppose I have a situation where the word that I am going to take the letters from have repetitive letters. Well, if you just think logically for a moment, that should cut down the number of arrangements you should have. Okay? So, what will happen, so just to give you an example, if I have the word dad, okay, since the D's repeat, I have the word dad, I have the word add, and I have the word DDA. Okay? That's all I'm going to get out of that because of the redundancy of the D's. So what we do mathematically is we take a look what letters are repeating. So let's take the word Mississippi. We have 4 I's, 4 S's, and 2 P's. So where we would have started is the same 11 factorial for the 11 letters of Mississippi, but we divide that by 4 factorial for the I's, 4 factorial for the S's, and 2 factorial for the P's. Now, in your calculator, you have to be very careful with this because what you need to do is you're going to put in the 11, go to math, factorial. When you put your denominator in, you need to put it in parentheses. Otherwise, it will not do that multiplication first. Then you do 4 factorial, 4 factorial again. Oh, one too many. There we go. And then 2 factorial. I know this is stimulating math, but nothing else I can do. Enter. Close your parentheses. Hit enter. And what happened? Oh, I forgot my division bar. All right. All right. Well, because that's making it multiplication. So I forgot my division bar between the 11 and the... So let me do this on my computer, which will make this a lot quicker. I apologize for that. 11. Because I want to make sure you see how you get the correct answer. Factorial divided by, all right, parentheses, 4, math, there. It's a lot quicker when I do it by the computer as opposed to the 4, math, factorial, and then 2, math. Oh, no, I want to delete that. too far. Temperamental calculators. Tutorial. All right, close, enter, and 34,650. Okay, which is what that equals. All right, sorry to belabor that, but I wanted to make sure you saw to do that. So if we do the same for each of these letters, these words down here, we get 6 factorial over 3 factorial, which is 120. 10 factorial over 2 and 2, which is 907,200. 11, 2, 2, 2, 4,989,600. What you should be doing is practicing these and making sure you're getting the same answer that I am getting so that you're familiar with the calculator, because this is a common Regents question. Okay, so hopefully you're realizing that what's happening here is every time I arrange the letters differently, I will get a different answer. All right, Jill has 8 quarters, 5 dimes, 3 nickels, and a penny. How many ways can she place them in a straight line? Okay, that means I have 17 coins, but I have a redundancy of 8, 5, and 3, which means she can do that 12,252,240 ways. Okay. All right. Now, let's get into some problems where it's not necessarily so easy to do with the factorials. So I have a car that has 3 body styles, 2 engines, and 2 transmissions. And what is the minimum number of cars the dealer must have? Oh, and 6 colors. Well, you remember your counting method. He needs, because you're going to need one of these, 72 different types of cars. Now, what's the probability we'll have a V6 engine in any color except blue? So if you think about it, each dash represents each of these choices. He can have all 3 body styles, but he can only have one of the engines, because we said it's got to be V6. He can only have 2, he could have the 2 transmissions, but only 5 colors, because he doesn't want the blue. So it's 30, and the probability is 30 out of 72, which is the total number of car arrangements. All right, next one. We have a 7-digit telephone number, and we want to know the number of phone numbers we can generate with the following conditions. So I'm going to put my 7, 1, 2, 3, 4, 5, 6, 7, 8, 1 too many. All right. And my restriction is the first digit cannot be 0 or 1. That means I have 8 to choose from. Okay. There doesn't tell me anything that they can't be used more than once. So that means all 10 are up for grabs. After that, so I have 8 million different phone numbers I can come up with. Now, what if the 4th digit cannot be 9? That means I can use 10, 10, 10, but only 9 numbers, and then 10 again, or 9 million different phone number arrangements. Okay. Now, next, I have students that are going to be sitting at an award ceremony. There's 6 of them. Now, if they can sit anywhere they want, it's either 6 factorial or 6p6. In either case, that's 720 different ways those students can sit. Okay? And again, when we're dealing with permutations, what we're talking about is the scenario where your order matters, and that means either arranged in an order, like a batting order or a seating order, or you're given titles, like president, vice president, treasurer, something like that. If all you are becoming is part of a team or committee where you have no title and you're not distinguished from somebody else, then that's not a permutation. All right. Now, the row must begin with a boy and end with a girl. So this is where this box method comes in. I got one too many again. Okay. So I have 3 boys and 3 girls. So they must begin with a boy. That's 3 choices. And end with a girl. That's 3. There. You always start with the restricted, or the spots that have a certain requirement. Now I filled 2 seats. I have 4 left. There's 4 for here, 3 for there, 2 for there, and 1 for there. Or 216 ways that seating arrangement could be met. Anthony and Gabby must sit in the middle 2 seats in any order. So, again, can't count these dashes. I have in the middle Anthony or Gabby. That's 2 of them. Once one of them takes it, that's down to 1, 4, 3, 2, 1. That's 48 different ways. Now, boys and girls must sit in alternate seats. So, I can have, let's say that's boys, girls, boys, girls, boys, girls. That multiplies to 36. So that was a boy, girl, boy, girl, boy, girl arrangement. I can flip that girl, boy, girl, boy, girl, boy, which means that'll be another 36. So there's 72 possible ways for that one. Eric and Doug must sit on the end seats. So I got Eric or Doug at the first seat, the other one's at the end seat, and I have the rest of my people, and that's 48. All right. So again, the key point for today's lesson is that a permutation represents an arrangement of objects where the order that they are arranged in matters, or the title given is of significance and makes a difference in what your arrangement is.